is a solution to an assignment question in coefficient of correlation. So before we move into the question, it will be good for us to understand the meaning of correlation, because that is a very, very important part of this assignment. That knowledge is important for you to understand the solution of this assignment question. So the definition of correlation simply means the act of comparison to find out the degree of relationship between two variables. Okay, now for you to define it in a more proper way, we can say correlation is a statistical tool. Statistical tool that helps to find out the degree of relationship between two variables. So now when we say variables, we are talking about simply things, various different things. So we can say, for example, the relationship between the buying of umbrella and rainy season. So the relation between the buying of umbrella and rainy season. So how well will people buy umbrellas when it's rainy season, and then when it's dry season also, or harmattan, how well will people buy umbrella? So those two things, when we are comparing them to see the relationship between the buying of umbrella or the purchase of umbrella and the season, the rainy season or the dry season, we are doing correlation. Another way to explain it is to say the comparison between the performance. The comparison of the performances in two subjects. For example, we have subject like mathematics. Mathematics. Maths is a subject that has calculations, and then we also have physics. Physics is another subject that also have calculations. So if we are taking a look at the performances of students in these two subjects, we want to see how these two subjects are related or similar in a way. That means a student who will do very well in maths, let's see the score of that student in physics. Let's know if there's any relationship between maths and physics. So when we do that, we are doing correlation. So that is why in this assignment you are given two subjects, economics and accounting, and you are asked to calculate the correlation coefficient using Spearman's formula and Karl Pearson's moment formula. Okay, so that's the first background you need to have about this assignment question. And secondly, you have to know that when calculating the correlation coefficient. Okay, first of all, let's talk about the correlation coefficient. What do we mean by correlation coefficient? Correlation coefficient is just simply the degree of this relationship. How strong is this relationship? How strong? Is it very strong, or is there no relationship at all? So just the way we define temperature as the degree of hotness or coldness of a body, and is represented in degrees Celsius or Fahrenheit or Kelvin. So the same way, if you want to know how strong is the relationship between these two variables we are actually comparing right now, we do that by finding out the coefficient of correlation, and the symbol for that is small arrow, and this also depends on the formula being used to do that, to get the coefficient of correlation. Now that leads us to the different methods or different types, the formulas that can be adopted. So when you want to know the degree of relationship between two variables, like you're giving economics, you're giving the scores of students in economics and accounting. So now you want to know the degree of relationship between this degree of relationship between these two subjects. Now there are several formulas that can be used. Now the two basic formulas which are actually adopted, the Spearman's correlation rank coefficient, coefficient of correlation. So Spearman. So, and the second one that is also used is the Karl Pearson. So now you can adopt any of these two formulas, but there are two other formulas. There are two other methods that can be used. In fact, there are other, apart from this, just the mathematical method. There are also graphical methods. So that's why you hear of things like scatter diagram, and I think that was also part of the question, scatter diagram. So you have to understand what scatter diagram is. Also a method of ascertaining the degree of relationship between two variables. So it's also a method of determining or ascertaining the coefficient of correlation between two variables. So apart from the Spearman's method, the Karl Pearson method, there are two methods that are adopted, which are not necessary for the scope of this assignment right now. And then we also have the graphical method. All right, so now we're going to move into methods which are important now, necessary for you to solve this question. So first of all, we'll start with the Spearman's method, and then we'll move on to the Karl Pearson's method. So that's just for this question. But if you love to have a more detailed explanation of this concept of correlation with clear examples, several examples, several solutions to several examples, which will be tackling, to be solving, so that whenever you find questions on this aspect, you just tackle them easily, because this is a simple aspect of statistics. It just requires your basic understanding of some certain things, which I'll be explaining in a special course that will be created for this purpose. So if you're interested in getting that course, just send a message to me on the number you are seeing right now on your screen, and you get access to that course. So you have solutions to several exercises. Please take this very, very important, and this is a one-time opportunity you're having. You may not have such opportunity like that to have detailed explanation to the particular concept that bothers you right now for your exams. So take good use of this opportunity to get clear explanations, just like the way you see it in this particular video. All right. Okay, now, so moving on to the solution to the question. The question says that the following data are the performance of 10 students in economics and accounting courses examination. So over here we have the data. So on this table, which you are seeing in red, this is the data. So E stands for economics and A stands for accounting. So we have a student who scored 58. A student who scored 58 in economics was scoring 59 in accounting. You can see, because of the closeness of the scores, and you can see the student who performed well in economics also performed well in accounting. Is there a relationship between economics and accounting? Another student who scored 60 and 58. Wow, you can see, look at the closeness. 58 now is a C, 60 is a B. So it's having a B in economics, having a C. Look at another one had 72 in economics, and it's having 73 in accounting. It's having A and A. Then the other one is having a B and a C also. This having a C and a C. So you can see, because of this, we want to find out what is the correlation between economics and accounting. So we are first of all going to use the Spearman's method before we go into the Karl Pearson's formula. All right, now, when you want to use the Spearman's method, first of all, you must understand that there are two formulas. There are two formulas that are involved in the Spearman's method. There are two formulas. Now, the first formula is this very one. The first formula is this very one. Arrow equals 1 minus summation d square all over n3 minus n. And this one is standing alone, and it relates with the entire fraction, which you can see here, not just only the numerator. So this is the first formula under the Spearman's method. Now, this formula should be used when there is no repetition of ranks, or when the repetition of ranks are not more than 2. Hope is clear. When there's no repetition of ranks, when ranks are not repeated. Now you wonder, what are ranks? What are ranks? Now a rank is simply a number that is given to a particular variable, a special and a unique variable. So we have different variables. Now in this case we have different scores. So let me be using the word scores. So we have different values under the variable. So variable x, variable y, which is like subject econs, subject account. So those are the variables. Now scores under the variables. So the first score we are having was 58 in economics and 59 in accounting. So the specific number of value that is attached to a specific score is called a rank in the Spearman's rank method. So when we discover that scores are repeating themselves in that particular variable or that particular subject, so a particular subject we're having two students scoring 58. Now we are seeing that score is being repeated. So because of that, there should be a repetition. There's a repetition of ranks. So you see it now, 58. There's a repetition of ranks. So in that case, we have rank being repeated. We have rank being repeated twice. So in that particular case, you can use this formula, or when all the scores are different, so there will be no repetition of ranks, so you can use this formula. But when we're not having about 3 students scoring the same score in a particular subject, there will have 3 ranks that are the same, and the ranks will be repeated 3 times, that is more than twice. In that case, this formula no longer holds. You can no longer use this formula when the ranks are repeated more than twice. That is, when there is the same score or the same value under the same variable more than twice, that is 3 and above, this formula should no longer be applied. Don't use the formula any longer. So I'll tell you another formula which you'll be making use of. So that leads us to the second formula for Spearman's method. Now, the second formula for Spearman's method is what you can see over here, Spearman's rank formula. So that is what you can see over here, Spearman's rank formula. So this formula is the formula that will be used. This very one is a formula that will be used when we are having the ranks repeated more than twice. So we are going to get a clear understanding of that later on. Okay, just to touch on it. Now, looking at this table which we have over here, in economics, for example, in economics, take a look at this score. Taking a look at this score here, we have 45 and we have 45 under the same subject, economics. So you can see that we're having two scores repeating itself. So here the rank will be repeated twice. So the first formula which I showed you before can work. But in the case where we are not having rank repeated more than twice, so let's see there's any example like that. 72. Okay, now look at under the same economics, we're having 72, 72, 72. So you can see that in this case now the rank is already repeated. A particular rank will be repeated more than twice. Now the rank that will be associated with 45 will be different from the rank that will be associated with 72. So for every given score whereby the rank is repeated more than twice, don't use that formula that I told you about. You use this new formula which I just showed you before I brought in this table again. So now we're having 72 occurring 3 times, meaning that there will be a unique rank that will be repeated more than twice. For that reason, this formula will no longer be the new formula, or the first formula I showed you, where we have r equals to 1 minus summation d squared over n cubed minus n, will no longer be applied, but the new formula will be applied. Let's explain the elements or the components of this formula. So you can see we are having arrow. Arrow stands for the rank, Spearman's rank coefficient. That is what arrow stands for. So it's different from the one where we have small letter arrow. So this big letter arrow indicates that we are using the Spearman's method. So it's 1 minus summation d square. This square which you can see over here, this square is simply referred to as the difference between the rank of the first variable and the rank of the second variable. So that is how we get d. So d square, summation of d square, we are going to calculate all the differences between the ranks in the first and second variable, and we'll create a column in our table for it, and then we'll calculate the sum of that d, and then that will give us the sum of d. Then we're going to calculate and get another column for d square, where we'll square all the d's, and then we'll calculate the sum. So that will give us the sum of d square, which we're talking about here. And here we have m. This m which you can see, m is actually talking about the number of times that rank was repeated for that specific score or that specific value. So now look at it here. Now when we are in the subject economics, we discover that 72 was repeated here, here, and here 3 times. So we are going to say that will be M1, first repetition of rank. M1 will be what? 3, because 72 was repeated 3 times. We move further and we see that 45 was repeated twice. That will be what? M2. That is the second repetition of rank. And the value will be what? 2, because that M2 was repeated twice. So that's the meaning of M. So M is simply the number of what? Of the repetition. That is how many times that particular score was repeated. So I hope it's clear. That's why you need that course, that video on more exercises and solutions, so that when you practice it and you watch more videos, you get used to these things. Okay, now so that is how we get our M. So we have different values for M1, M2. Then we have Mn here. Mn simply means that whatever number of n, whatever number of repetition we now get to, whatever number of, or whatever score, whatever number of times we see rank being repeated, that is now n, mn, whatever number of times. So this n here is different. This n here is different from the n which you see at the bottom. So the n which you see at the bottom is simply that n there is the number of variables, number of scores, the number of values. That is what that n understands for, the number of scores. So the number of scores is what, or number of students. You can see that number of scores, the number of students, or the number of values which we have on the variable. So we have 10 students here because we are giving 10 scores each for each subject. So that means our n will be 10. So when you are done, you put the values into the formula and you get your answer. It's very, very simple. And when you have a scientific calculator that can do it, you can put everything just at a go and you get your answer, except you are not working on a theoretical question where you have to show your working in detail. So now from the formulas determine the type of table that will be drawn. Now this is one secret to dealing with, to solving or tackling statistics question. This one secret. Now you may be wondering, how do I cram these complex tables? How do I cram these tables? Well, how do I know what columns to create in the tables? Now you can see here that we are having dx, we are having dy. This is not differentiation. The x simply means deviation of x. Deviation is the difference between the value of x and the assumed mean of x. So we'll talk about that. And deviation of y, the value of y minus the assumed mean of yb. Then we have summation dx, which is the sum total of all the dx. And then we have dy squared, which is just square each dx, square each dy. And the n here still means the number of scores or number of students. So how do you know what columns to create in your table? To know what columns to create in your table is to come and simply check your formula. Check the formula you want to use. If you are to find standard deviation, or you're asked to find standard deviation, for example, or you're asked to find mean, or you're asked to find whatever thing you're asked to find in statistics, and you know you have to create a table. How do you know what columns should be in that table? Check the formula which you are going to use to solve that particular thing which you have been asked to find, and those elements you find in the formulas will give you a clue to what to do on your table. Now we are using the Spearman's method, which has to do with this formula. We're using the Spearman's method, which has to do with this first formula, which has capital letter R. So now we're going to create a table for that. That means our table should have D square. Our table should have D. So for the Spearman's rank formula method, this is the table which we shall be making use of. This very table which we have here. So that's the table we are going to be making use of to solve the question, this very table. So you can see on this table we are having x column. We're having a column for x, which is this. We're having a column for x, which is everything you find here. And then we are also having column for y. We're having a column for rx, ry, d, and d square. So now these columns, these various columns are created based on the need in the formula, Okay, so x and y. X is simply meant to stand for economics, and y stands for accounting. So arrow is the rank of x, and arrow x is the rank of x, and arrow y is the rank of y. Then d is the difference in the rank, and d square is the square of d. Simple. So you can see this is just the formula. This is the table you need, and you can get a clue of all these elements in the table from the formula which you are using. So that's that about the table. So now, how do we fill in the table? This table here is filled already, but I'm going to explain in detail how it was filled up. So now x and y, when filling in the values in under x and y, we are going to choose one method. This is when working with the Spearman's method. Now you choose one method from ascending or descending order. So one of those methods, when I mean method now, I'm talking about the ascending and descending order now. Among these two order of writing numbers, you choose one of them. So if you are choosing ascending order, you use ascending order for both variables, that is x and y. Or if you are using descending order, you use it for both variables, that is x and y. Okay. Now we have chosen to use what? Ascending order. Now that's what we have here. You can see it's going from 30 to 45 to 45 to 55 to 58. So we are moving from top to the bottom in ascending order. So that is why what we did for the x and for the y variables, which is economics and accounting. So now we carefully arrange it. When arranging it from the question, you have to be careful not to miss any number, because once you miss a number, it can affect your answer. Yes, that is why you have to be careful when solving statistics questions. So now, we will take x first. You assume you have an empty table now. You are filling them gradually from column x down to d square. So now for x, when we have 30, we ascend a rank 1. Why? Because that is the first score. Now we move to 45. we should assign a rank 2. We should assign a rank 2. But wait, 45 is occurring twice. So we can't just assign a rank 2. This 45 occurring twice shows that there is a repetition of rank. And when there is a repetition of rank, what you do is that you say, since there's repetition of rank, so what you do is this: you say, okay, the first 45 supposed to take 2. The first 45 was supposed to take the rank 2. Then the second one will take the rank 3. So we add both of them and find the average. So 2 plus 3 divided by the number of elements, which is 2. That will give us 2.5. So 2.5 is going to be the value of the rank, which will be assigned to the both 45 scores. So that is why we are which we assign to the both 45 scores. So that's why we're having 2.5 and 2.5 attached to the both 45 scores, which we have on the X column. We are dealing with the X, so I have not come to the Y. Now, moving on, we stopped at, then you note where you stopped. The last rank which you stopped, which was 3. Because we said one would take 2, the other one would take 3, but we added them and found the average to be 2.5. But we actually stopped at 3 now. So the next one will be 4, which is what? 55 will not take 4. Then the next one is 58 to take 5. Then the next one is 60. 60 now is what? Occurring 2 times. So we'll do the same thing. 60 ought to be 6, because when we stopped at 5 here, the next one is supposed to be 6. So we'll say 6 plus what? 7. That is, the first 60 will be taking the rank of 6, and the second 60 will be taking the rank of 7. So divided by the number of numbers there, number of values, which is 2, that will give us 6.5. That will give us 6.5. So that is why we're having 6.5 here and 6.5 here. So that's how we'll do it for every other value under the X column. Now we see 72 occurring twice. We'll do the same thing. But where did we stop? We stopped at 7. So we'll continue from there. The first 72, now we have 7. There's a mistake on the table. The 72 actually occurred 3 times. So there is another 72 here. So sorry, just have to correct that. There was a mistake on the table. I just discovered that now on the table drawn. There was a mistake on the table drawn. So there is another 72 here. There's another 72. I mean, it's not complete. So when you check a question, you discover that is true. That is correct. Checking the assignment question, which was given. Okay, look at it from the table here. You can see we're having 72 occurring 3 times. We're having 72 occurring 3 times. 1, 1, 1. So that means on the X column something was wrong, which has been corrected. So the same thing is also happening on the Y column. There's something also not complete there, so we have to fix that. All right, so now 7 plus 8 plus, then the next 72 we have the rank of 9. So 7 plus 8 plus 9, that will give us 27. So 27 divided by 3 will give us 9. So that is why we are having 9, 9, 9, and there's going to be another 9 here. 999. So because the table has to be complete. So when we have a new value for 72, there will be a new value for the rank X, and there will also be a new value here for rank Y, because there is still going to be a value. There's still going to be a value here. All right, so you just complete the table on your own, right there on your paper where you are taking down notes. So that is how we get the values of ROX on the table. Now, another thing you have to note here is that this first rank which we saw, the first time we saw rank be repeated, we call it M1. The second time we saw rank be repeated, we call it M2. And the third time we saw rank being repeated, we call it what? M3. We'll call it M3. So then the fourth time we will see rank be repeated. It can now be in the next column, but it cannot be in the Y column, but we'll still call it M4. We'll continue. Now, how many times were the rank repeated in the first case? The ranks were repeated how many times? Twice, which is 2 and 3. So we have rank being repeated twice, because in that case it was 45. We had 45. We had 145 here, and we had another 45. So that is 2 times. So that means M1 will be assigned a value of 2. M1 will be assigned a value of 2, and then M2 will be assigned a value of 2, because rank was also repeated twice here. And then M3 will be assigned a value of 3, not because it's M3, but because rank was repeated 3 times. So do not forget that, because that is what we're going to use in the formula. Then we'll move on to the next column, which is column Y. So for column Y, the very first element here, the very first score will be assigned a rank of 1. The next score will be assigned a rank of 2. The next score will be assigned a rank of 3. And then we are having 58 occurring 3 times. So as we have done for the X column, we are going to add up these 3 scores, 58 plus 50, sorry, not 58. We are going to come back here. Please don't get confused. We do not add up the scores. We add up the next value of the rank on the rank column. We stopped at what? We stopped at 3. So the next value on the rank column is supposed to be 4, right? When you get to a new rank column, you start from beginning again. It's only the M you continue naming, M3, M4, M5. But when you come to the ranking, you start from the beginning again, from 1 again, right? So now this is the 4th time we are seeing rank be repeated. That is 58, 58, 58, the 4th time. So we call it M4. But now the first 58 is supposed to be taking a value of 4 because we stopped at 3. So the first 58 is supposed to be taking a value of 4. But since we have 58 occurring 3 times, so we will say 4, 5, 6. So 4 plus 5 plus 6 will be giving us 4 plus 5 plus 6 will be giving us a value 15, which will divide by 3 to give us 5. So that is why we're having 5, 5, 5. So we now assign that 5, which is the average of these 3 numbers, to the 3 scores that are repeating themselves. You understand? So then we move to 59. So, but note where we stopped. We have stopped at what? 6. We stopped at rank 6. So 59 now should be taking a rank of 7, but 59 is also repeated twice. So it will be 7 plus 8. 7 plus 8, that will be giving us the value of 15. So since it's just twice, it's been repeated, we'll say 15 divided by 2. So that will give us 7.5, 7.5. And then we see 60. 60 now is repeated. 60 is, okay, 60 is just 60 is just once. 60 is just one because I have to confirm from my table since this is not complete. So 60 is once. Then what we have under here is 73. So please complete it. You can check your table and complete. You can check the table of values which is giving the question and complete it. So 50, after 60 we have 73. So now we stopped at what? We stopped at 8 because the first 59 was having a rank 7, second 59 was having a rank 8, so we added 7 plus 8 and divided by 2, that gave us 77.5. Now 60 will be having a rank of 9, so that's why we have 9 here, and then 73 will be having a rank of 10. This is not 1.0, please, this is 10. Okay, so that's how we feed in the values of x, y, arrow x, and arrow y. So now once you are done with that, you are almost done with this, almost done with the solution. D is just simply saying, okay, you can note this down somewhere. D is equal to arrow 1 minus arrow 2. So arrow 1 is simply the first variable and arrow 2 the second variable. So our first variable is x, so that means D is arrow x minus arrow y for this question. And X stands for economics, Y stands for what? Accounting. So we are going to use that to find the value of D. So in this case now, we are going to say arrow X is what? For the first score, which is 30. 30, that is arrow X is 1 for 30. 1 minus 1 gives 0, which we have here. Then 2.5 minus 2 gives 0.5, which we have here. Then 2.5 minus 3 will give minus 0.5, which we have here. Then 4 minus 5 will give minus 1, which we have here. 5 minus 5 will give 0, which we have here. 6.5 minus 5 will give 1.5, which we have here. 6.5 minus 7.5 will give this value, which we have here. So 9 minus 7.5 will give this value, which we have here. And 9 minus 9 will give this value, which we have here. And then 9 minus 10 we give minus 1. So minus 1 will be under 0 in that particular column to complete it. And then we move on to the next column, which is D square. So D square simply means scoring all the D. So we'll say 0 square gives 0. We'll say 0.5 square gives 0.25. Please, when doing this, don't assume that you know it. Use your calculator when you get to decimal because you can make a mistake. So minus 0.5 square gives 0.25. And then this squared gives this, and 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 this squared gives this. So, and then 0 squared gives 0, and then minus 1 squared will give 1. So 1 will be the value to complete that column there. All right, so I hope it's clear. So with this, we are done with the table for the Spearman's rank coefficient formula method. So we are going to now go to our formula and then get every necessary thing. So back to the formula which I displayed before. So this is the formula over here. So from the formula, we can see that we are in need of our M1, M2, M3, M4, and M5. So we have up to M5. We have up to M5. So since we have up to M5, our formula will span up to what? Our formula will span, so our n here will be what? 5n. So we're going to have M2, M3, M4, and M5. So we're going to copy this formula somewhere and we're going to use it to solve. So the formula now, we are having, summation. So we're having summation d squared. So we're having summation d squared plus 1 over 12. So summation d squared, how do you get summation d squared? Summation d squared is simply going back to your table and on your table, you go to the column for d squared and you sum up everything. You sum up everything that you have here. That will give you summation d squared. So you put the value in the place of summation d squared, which I just wrote down in the formula. So summation d squared, we're having summation d squared plus 1 over 2, and then we'll continue. We have m1 cube minus m1. That is what we should have here. m1 cube minus m1. Then we'll continue plus 1 over 12 m2 cube minus m2. Then it permits me to continue under plus 1 over 12 m3 cube minus m3 plus 1 over 12. So we'll keep on doing it until we get to the maximum number of repetition of ranks, which was 5. Minus n5. So when you are done, you put the division sign divided by n cube minus n, and then told you before that n here now is the number of scores, and then we are having 1 minus this overall fraction. So this is what we are going to be having. So just write your own what we are having here. Write it up in a straight linear, in a straight line. So when you calculate the value of d squared, summation d squared will give 22.5. So it means that our formula will become 1 minus 22.5 plus 1 over 12 into, what's the value of m1? M1 is 2, like I explained before. M1 is 2, so we have 2 cubed minus 2. So M2 is, so you continue plus, please write it in a straight line, go the space, that's why I'm bringing it down. So M2 is what? M2 is also 2. We have 2 cubed minus 2 plus 1 over 12. M3 is 3, so we have 3 cubed minus 3 plus 1 over 12. M4 is 3. I think I didn't talk about that, but M4 is now found on the Y column. It was on the Y column we found M4 because we only saw that scores were repeated on the X column 3 times. That is M1 to M3. So the next repetition took place on the Y column. So the first repetition on the Y column is what we call M4, and that particular score was repeated 3 times, which is 58. So you can check your table and see 58 on column Y was repeated 3 times. That was M4. Then the next time we saw a rank being repeated again was on the same column Y. This time around it was 59 and it was repeated twice. So that makes us to have plus 1 over 12. This time around we are in M5 now. So M5 is 2. 59 repeated twice. So then this all over the number of scores is 10, so 10 cubed minus 10. So this is what you have. So you can type this on your calculator directly, and when you type this, okay, now you can see this one is going to confuse some persons. So let me bring it to where it's supposed to be as per the equation is concerned. So 1 minus, so that's how it's supposed to be. So to have, so that's how it's supposed to be. So 1 minus everything you have here. So you can type it on your calculator for it to be, for you to get the direct answer. Make sure you use it. If you don't have a calculator that can take all the variables, all the values exactly the way it should be, then please make sure you do well to solve them bit by bit, and then solve them bit by bit. So take all the brackets and solve everything in the bracket first, and then you multiply with the fractions 1 over 12, 1 over 12, 1 over 12. Eventually you add up everything you have, then you go to denominator and you do the same thing there. Okay, now, but for those who want to solve it with the scientific calculator, let me just quickly show you a way you can actually do that. Okay, 6 will come into this place first, and then you have a bracket. So I'm going to explain why 6 is coming there. Just take it like that for now. So I'm going to explain why 6 is actually coming in there. And then summation d square was 22.5 plus, we have another fraction 1 over 12. Then we had the bracket where we had our m1, which was 2, use the power of 3 minus 2, we close the bracket. Then you have plus so this is the fourth rank, which is 3. So you have to be very, very careful when solving this kind of question. The fifth rank was 2. All right, so I noticed something was missing from the formula. The formula, there was an omission in the formula. The formula is supposed to be having 6. Sorry for that omission. Please make sure you take note of this. Please make sure you take note of this. It's very, very important. If this is not in your formula, your solution will be very, 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 very wrong. Sorry for this omission. Very, very sorry for this omission. So we are supposed to be having 6 multiplied by everything we are having here. Yes, 6 multiplied by everything we are having there. So that is the formula. So that means we are going to have, back to our solution, that means there's going to be a 6 here. So that is the reason why there's going to be a 6 outside. So that is the reason why I added that 6 in the calculation, which I did on the calculator. Good. So now doing this, the answer which we got was the answer which we got was approximately 0.83. Okay, so let me quickly say this here. Now, the idea when solving for coefficient of correlation is just to have a clue of the degree of relationship. Just to have a clue of the degree of relationship. So if you use another formula to solve this thing, you may get 0.88 or you may get 0.9. Now you notice that these three numbers. Now you notice that these three numbers are actually close, very, 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 very close. So they are within a particular range. So that means that there is the same level of relationship. So with whichever formula you use, even if you get another answer that is slightly different from this, slightly different, you know that in all the same is showing that there is the same degree of relationship. So that brings us to what we call the degree, the type of correlation. So there are 4 types of correlation. We have the high positive correlation, we have the high positive relationship, the high negative relationship or high negative correlation, and then we have the zero correlation, and then we have the non-linear correlation. So high positive correlation, high negative correlation, zero correlation, and high negative correlation. So with the Spearman's rank method, we have an expression like this. Now this simply means this is the Spearman's coefficient, degree of coefficient. So when the degree of coefficient arrow is greater than or equal to -1, and is also what? Less than or equal to 1. So it means that when we are solving for the degree of correlation, we should be expecting our answer within this range. It's either it's equal to -1 or it should be greater than -1, not less than. A number that is less than -1 is what? -2, -3. Those are numbers less than -1. So we should not be expecting anything -2, -3, -5, -100. We should be expecting -1 or -0.8, -0.7, -0.5. Those are less than -1. So that is why now we are having 0.8. So when we are also climbing upwards, we should not expect anything like 2, 3, 4. Those are above 1 because it should be what? Less than or equal to 1. So it's either equal to 1 or less than 1. So we should be having 1, 0.9, 0.7, 0.2. Now, whenever this side indicates high positive correlation, this side indicates what? High negative correlation. So this is how to interpret your answer. So whenever you solve and you get a number that is close to +1, you interpret it as the two subjects or the two variables are having what? A high positive correlation. But when the answer you get is related to -1, maybe -0.8, -0.7, -0.9 something, that is what? High negative correlation. So you now interpret and say that from the calculation, it was discovered that the two variables or the two subjects are having a high positive correlation or a high negative correlation, or you can say a high positive relationship or a high negative relationship. So you can see it now. So that is how to interpret your answer. You are asked also to interpret the answer. Alright, so if you want to know more about the other types of correlation, zero correlation and non-linear correlation, do well to get my course on correlation. I'm emphasizing it. Get my course on correlation and make sure you go through it so that you can understand all these other things in detail, you can understand it better. So now the answer we got is what? 0.83. Now we're going to use the Karl Pearson's method and see if the Karl Pearson's method will also give us the same answer or an answer in the same range of 0.83. There are two formulas, not just two formulas, there are two methods under this Karl Pearson's formula method. There are two methods, two ways of doing it. So the first way is to use the actual mean method. So we call it the actual. So we call the first method the actual mean or the direct mean method, and then the other one is the assumed mean method. So the assumed, like assumption, assumed mean method. Okay, now when we say direct method or the actual mean, that means that we're going to find the mean of X and the mean of Y. Right? Now the mean of the scores in economics and the mean of the scores in accounting. That is if we are using the actual method or the direct method. The actual mean method rather. So now if we are using the assumed mean method, it means that we are going to assume a mean for the economic scores and also assume a mean for the accounting scores. Now, how do you know which of these methods to use? Now, when you say your values are large, like large values, just like the ones you're having in this assignment question, you have large values, you go for the assuming method. But when you have small values like 5, 4, 2, that you can easily add up and subtract, you use the actual mean method. But with any formula you use, you will get the same answer, or as I've explained, the answer will be the same range. Now, you may check Google and you find a formula different from the one which I've given to you for this solution. Now, don't be confused. There are different formulas that you can use for the Karl Pearson's method, but whichever formula you use, you should get the same answer or within the same range if you actually use the formula very well. So there are different formulas. So you may check another textbook and you find another formula. There are different formulas that can be adopted. But you can know this formula and use it to solve in as much as you get the same answer or an answer within the same range so that you can interpret your results correctly. Okay, now how do we use the Karl Pearson's formula? The Karl Pearson's formula again. Write the formula again. So the coefficient of correlation, or the Karl Pearson's coefficient of correlation, is given by small arrow. So it's given by small arrow. It's the Spearman's rank coefficient that is given by the big arrow. So small arrow, small arrow, small arrow is equals to summation dx dy minus summation dx multiplied by summation dy divided by n, and this is all divided by square root of summation dx squared minus summation dx over n, but this is all squared. Then this is multiplied by square root of summation dy squared minus summation dy all squared over n. So this is the formula which is used to find out the coefficient of correlation using the Karl Pearson's mathematical model. Okay, so now from the formula again, you have an idea of what should be in our table. So from this formula, you can see that we are having the x, the y. Now this is not calculus. The x here, which you see, represents deviation. So it means deviation of x, and the deviation is simply the difference between the assumed mean and the actual value of x. So I will explain that. Then you have summation dx. So summation dx should be in our table. Summation dy should be in our table. Summation dx square. So we should have dy dx and dx square in our table. Okay, the summation is actually the total of all the dx. So it's that summation dx. Then we should have dy square on our table. So now quickly, I would like to say this now. But when you are given a question in correlation and you're asked to find the coefficient of correlation. Now, just like this question, this one you're asked to use both method, the Spearman's method and the Karl Pearson's method. But just in case you're not specified what method to use, how do you actually know the exact method that you are going to use? So I'm going to mention that in the course, in the detailed complete course in correlation. So make sure you get that course. Okay, now for this one, we are having the arrow, small arrow, and that is the coefficient of correlation for Karl Pearson. Now I talked about deviation dx. So deviation dx is the difference between the value of x and the assumed mean of the variable x. Now, why are we talking about assumed mean? The reason we are talking about assumed mean is because there are two methods. There are two ways of applying the Karl Pearson's formula. Now, the first way is the actual mean method. And then the second way is the assumed mean method. So we have actual mean method and then we have assumed mean method. Now, how do you know which of the methods to use? Now, for you to know the method to use, to check your question, if the numbers you are giving, like the scores now, if the scores are large, like just where we have 58, 70, 60, these are large numbers, you use the assumed mean method because the numbers are large. But if the numbers are small, that you can easily add and subtract, like 5, 4, 2, 3, you use the actual mean method. So both of them, they have their different formulas. So the formula which I have given to us now is the formula for the assumed mean method, and that's the one we are working with. So when we're talking about assumed mean method, we are going to find the assumed mean. We are going to find the assumed mean of each of the variables. So now for economics, we find the assumed mean of economics, of all the scores in economics, and for accounting, we find the assumed mean. But for the actual mean method, we find the actual mean. So we get the assumed mean from the actual mean. So first of all, you find the mean. No, mean is the summation of all the very scores we have there divided by the number of scores. So that is what gives us the mean. So the mean becomes this by x, and then the assumed mean is going to be an integer. We just assume any number. And then we take that as our assuming. So the deviation now becomes the value of x, each value of x minus that assuming. So we'll call the assuming of x a, and we'll call the assuming of y b. So that's what we're going to do in this. So then we're going to go back to the table. So from the table now, we're going to go to the table for Karl Pearson's model. So this is how you draw the table for the Karl Pearson model. The table here already has been drawn, but I'm going to explain how. So on the table which you can see here, we're already having columns. We're already having columns for x, y, dx. Now we're talking about this particular table. That is this. That is what we're talking about now. So we're having columns for x, y, dx, dy, dx squared, dy squared, and all of that. So that is what I'm talking about. From the formulas, you know that these are the columns that are necessary. So now you again put in the scores for all the x, all the scores under x. X stands for economics, and then all the scores under y, which stands for accounting. Put in. So finding the mean of the x now. So when you find the mean of the x, it will give a value of 56.5. To give a value of 56.5. So we can write over here that the mean of x is 56.5. And then when you find the mean of y, it will give you a value of 54. So the mean of y is 54. Now for the assuming, we are just going to assume any number because we don't want decimal, we want to take an integer. So for us to take a whole number, we just take 56 as a mean. That's how we call it assume mean. So you can assume any number, but I advise you take something from the mean which you have found. So you don't take 56, and then for the assuming of y, it will still be 54. Alright, so then the next thing we need to find now our assumed mean, which is a for x is what 56, and b is for y, and that is what 54. So now the next thing we have to find is the x. So like I said before, the x is the difference between the particular score and the assumed mean. So for x now, work on the x column first. So the x score here is 30. So 30 minus the assumed mean is 56, right? So 30 minus 56 will give you this value minus 26. So then we go to the next value, which is 45 minus 56. So we're going to be subtracting that 56, which is the assumed mean, from each and every one of these values of x, these scores, and then we'll put their corresponding values in the column of the x. So that is how we get that's how we fill the column of the x. Then we'll go to dy. The column of dy now, we're going to take each of the scores of y and subtract the assumed mean of y from it. So the assumed mean of y is 54. So we'll say 30 minus 54 will give minus 24. 35 minus 54 will give this. So that is how we'll get all the values for the dy. So that's how we get the values for the dy. Now when we are done with that, then you just simply take for the ds, this is the ds square column now. You just take each of the score. Now when you are taking this dx here, you square the s, square minus 26, it will give you this. So that is how we get the x square. Now you go to the next one, you square minus 11, it will give you 121. Then you square the other minus 11, it will give you 121 again. Then you square minus 1, to give you 1. So make sure you use your calculator to do this, especially when it comes to minus. When you are doing it, put it in a bracket. So if you want to type in your calculator, you type something like this, you put a bracket before you square it so that you get the correct answer. Because when you say minus 1 square, it's the same thing as saying minus 1 times minus 1. So the negative sign auto, minus times minus will give plus, so give plus 1. So if you don't do it that way, you may get the wrong answer. So that is how we fill in the column of the s square, and we'll do the same thing to get the dy. So for dy now, we'll take the first score, which is the first dy, which is minus 24, and score it. It will give us 576. We'll take the second one and score it. It will give us this. Then we'll take the next one, which is minus 4, and score it. It will give us this. So that is how we fill in all the values of the dy square. And then we'll go to the x dy. The x dy is simply the product of each the x and dy. So for example, I'll just give an example, and then you just do the rest on your notes which you are solving with there. Now this is the x, for example. So we'll say the x times the y will give this, the value of this, the x, the y here in this column. So we take it according to the rows. So here the x times the y will give this, the x times the y will give this, the x times the y will give this. So that is how you fill in all the x, the y according to the rows. The way I've just drawn a line. So make sure everything is accurate. And when you are solving questions like this in statistics, you must be very, very careful and patient so that you will not make mistake. If possible, go back again to check, to confirm. After you have finished computing your dx or your summation of x dx, you go back and do it again. Do it at least 2 times so that you don't make mistake. Otherwise, you think that you have gotten it, or you made one mistake somewhere that can make you feel get it wrong. So now when you have done all that, then you come back to your formula. And then you simply input what you have solved, everything which you need. You input it into the formula which was given here, and then when you do that, you get something like this. So the value of our summation dx dy, summation dx dy is simply, you go and sum up everything you have in this dx dy column. That is what gives you summation dx dy. Then when you sum up everything you have in this dx square column, it gives you summation dx. So that is how you get everything that you need to impute in your formula. And so once you have done that, then you impute the values. You impute the values which you got in your formulas. And so when you do summation dx dy, the value you get is going to be, so we'll just say arrow is equals to summation dx dy. When you do that, you get 1320 minus summation dx is 9 and summation dy is 0. So this divided by n, which is 10, then all over square root of summation dx square is 1723. So this minus summation dx is 9. So that summation dx, all of them will be squared, divided by what? 10. Then this will be multiplied by the square root of summation dy square is going to be 1343. So you do that by computing the total, every value you have in the dy square column. That's what will give you summation dy square. Now this minus summation dy is 0. So all of that square. You must make sure you understand this formula very well before you use it, so that you will not get your answer wrong. So just go back and check. And if you want to understand it better, get the course which I've talked about on more solutions to questions with that correlation. It's very, very important. Very, very important, so that you can understand everything better. So when you compute this in your calculator, you will get your answer directly. So for those who will be using their calculator to solve it directly, so I'll just show you an example of how you do it. So if this is your calculator screen, now you are going to activate the fraction command, or press the fraction button, and then you type in the first value 1320 for summation dx dy. Then you put a minus and activate another fraction command, and then you are going to put a bracket 9. So you can do it like this so that you'll be sure to get the correct answer after your computation. So you have to be very careful with questions like this that are having complex calculations in a way. So 1732 or 1723 minus, you activate, always use the fraction button where you have a fraction. So this all squared coming down having 10, then you come out again so that you can activate its times operation, and then before you open the new square root, then here you have 1343 minus, you put a fraction there, 0 in a bracket. So make sure you put the bracket, and then you have a square, and then you come down 10. So at the end of the day, we got our arrow to be equal to 0.87. Now this is close to what we had before for the answer when we used the Spearman's rank method, and that was about 0.82 or 0.83 or thereabout. So the value which you got there is related to this one. Now what do you see? That both of them are related to each other. So let's say for the arrow we had 0.82, and now we're having 0.83. So you can see that both of them, they are around the same range, just about a difference of 0.05. Okay, now this both of them show a high positive coefficient or a high positive relationship between these two subjects. So now the idea of the idea of these solutions or this mathematical model of finding the coefficient of correlation is not just to give you an exact answer. I think I said that before. Your answer must not necessarily be the same for whatever formulas you are using, but it's going to show you the degree of relationship in this expression, which shows the Spearman's rank coefficient of correlation. All right, now when it's negative one, this means that there is a high negative coefficient, and when it's positive one, this means that there is a high positive coefficient. So now that is where the interpretation of your answer comes into play. So whenever we're having our answer within the range of +1, that is either 1 or 0.9 or 0.87. So whenever you have any value within this range, you know that there's a high positive correlation. And whenever you have any value within the range of minus 0.5, minus 0.6, minus 0. It's having minus, but it's not less than -1, and you're just having a negative sign, so minus, and it's close to -1. So you know there's a high negative correlation. So that is how to interpret it. So now for this our question, which we're having 0.87 and 0.82 as our answer. So this shows that at the end of the day, we can conclude that there's a high positive correlation coefficient. So we had a high positive correlation coefficient. So there is a high positive correlation between economics and accounting. So that is the interpretation of the question. So there is a high positive relationship or correlation between the two subjects, economics and accounting. And also for the other questions which we asked to answer, just write brief note on them on correlation coefficient. And the correlation coefficient is simply the degree of relationship between two variables. So that is what we are trying to ascertain using this model. So there are different methods of ascertaining the coefficient of correlation between two variables. We have the mathematical model, and we also have the graphical model. So in the graphical model, we have the use of simple graph and scatter diagram, which is also referred to as dot diagram. Then under the mathematical model, there are four methods that are used: the Karl Pearson's coefficient method, the Spearman's rank coefficient method, the two-way frequency table, and the concurrent deviation method. So these are the four methods that are used in that aspect. So if you want to have some ideas about those other two formulas, get the course which I've talked about in correlation. Contact the number which you see on your screen and get the course. And then for the scatter diagram is simply a graphical method of ascertaining the coefficient of correlation. So you can just search something on that more on your Google, or just search something on that more to make up your brief notes on that. And then when I've talked about the high positive coefficient, a high positive coefficient is simply a value that is within the range of +1. So anybody that is within the range of +1 falls into the high positive coefficient category, and it shows a high or a strong relationship between the two variables that have been studied, that have been compared in your with your formulas which you actually use. So in this video we have actually talked about the coefficient of correlation using the Spearman's method and the Karl Pearson's method. I've given you some of the formulas. Now I also like you to know that there are several formulas which you can use for the Karl Pearson's method apart from this one which I've used here. So in case you check your Google or you get a textbook and then you find a different formula, don't be surprised. There are different formulas, but if you apply the formulas properly, they should give you the same answer or answer that are within the same range, so that you can interpret correctly. All right, so that is all for this video. So just to remind you that Jesus loves you. If you have not given your life to Jesus Christ yet, you must do so. You must give your life to Jesus Christ. You must understand that without Jesus Christ as a student, no matter what you get, even if you get your distinction, you get your first class or anything, it will amount to nothing, to be useless, because you cannot have everything and then you go to hell and expect to be happy. You will regret everything. But if you have your distinction, your first class with Jesus Christ, you'll be fulfilled here on earth and also fulfilled in eternity. So I'm urging you and pleading with you to consider giving your life to Jesus Christ if you have not done so. And if you have done so, make sure you stay with Jesus and serve Him, because there's nothing else that you can get in this world that will give you full joy and satisfaction apart from Jesus Christ. So make sure that you give your life to Jesus Christ. It's very, very important, and it can also help you to get inspiration on how to get around your studies more easily. And as you do so, the Lord bless you in Jesus' name. All right. So I want to also use this opportunity to ask you to recommend Detailed Learning Institute to any secondary school students which you know around you. Apart from this assignment, solution which you have just gone through now, Detailed Learning Institute provides explanations to students in secondary schools. Any student in secondary school classes, either senior secondary or junior secondary, you can just please connect them with Detail Learning Institute with that number which you can see on your screen, and they can get quality videos just like as you have watched now. They can get mathematics explained to them thoroughly, and physics and other subjects that will be enlisted into our program. And as you do so, may God bless you in Jesus' name. God bless you.